Okay, so now we want to look at Pascal's Law and how we want to find the force and the pressure on the side of a tank. And we're going to assume a not sealed container just to make all these kind of the same, whether we're inside the tank or outside the tank with the fluid. Okay, so again, we've got our tank sitting here. Right, so as the tank goes around, it's filled up with some fluid, right? So we'll call this the petrochemical that it's filled up with. So this is all full, right? The green stuff in the tank. And what's happening is it's pushing on the outsides of the tank, right? Pushing this way and that way. Here, if I draw it from the top, might be easier to see, right? The fluid's pushing on the outsides of the tank. It's also pushing down on the bottom of the tank. Okay, we just don't see that as much, or it's harder to see from the way I drew it. But if we just draw one wall of the tank, like we cut the wall in half, right? We're looking inside the tank. Now my fluid is sitting here like this. Okay, that fluid is exerting a pressure on the outside wall. That pressure at the bottom of the tank is much more, and it gets less and less and less and less until at the top of the fluid there's no pressure. Okay, at the very top, and up here above the fluid, of course, there's no pressure from the fluid. Okay, now again at the bottom of this tank here, the fluid is also pushing down, but we're just worried about the wall, so we don't care about this up and down pressure. We're just looking at the pressure at the wall. Now pressure, when we're doing it like this, we're just going to look at the gauge pressure. What is the pressure from the fluid? Not caused by the atmosphere up and above. That doesn't change throughout because the atmosphere is pushing for all of them. So we're just going to look at the gauge pressure. Okay, so we're just going to call that pressure gauge. And that is equal to the density times acceleration due to gravity times the height. And this height, I look at it more like depth. It's how high is it from here, right? So it's really the depth, how far from here down to where I'm measuring. We're going to look at two spots. We're going to look at the pressure at the top. We're going to look at the pressure at the bottom. Okay, so pressure at the top, and again, we're always talking about gauge pressure in this case, is just rho GH, but in this case, H equals to 0, so the pressure at the top is equal to 0. Then we're going to look at the pressure at the bottom. Okay, the pressure at the bottom is rho GH, and again, that H is now the full height of the liquid. And in this case, they didn't call that H, right? They said the height of the petrochemical, they called it L. Again, we want to convert that into inches, but that's going to be L. So the pressure at the bottom, for our case, is going to be the density times acceleration due to gravity, okay, times the height, which they called L. And so all you can do is you're going to plug your numbers in there. You've got the density. You can look up either in your formula sheet or on the internet what the acceleration due to gravity is. Okay, and then we want our L, our height. Now, we want to find the average pressure. And so when we're looking at average pressure, we're just going to take the pressure at the top. We're going to add it to the pressure at the bottom. We're going to divide that by 2 because that's how you find an average, right? If you add two things together and divide by 2, it'll find the average. We said the pressure at the top was 0. So this is just really equal to the pressure at the bottom divided by 2. That's the average pressure. So just find your pressure at the bottom, divide it by 2, and you have the average pressure, because that's what they were asking for. Then it says, what's the average force? Well, we know that pressure is equal to force over area. That means force is equal to pressure times area. If we take the average pressure that we just found, we will end up with the average force, which is what we were looking for. And that's all there is to it. So I will let you plug in the numbers, because I think you can do all that. But really, there's how you find force, and there's how you find pressure, right? Don't forget that it's rho GH. And in this case, the H is L. And there you go. It's the same for 6 and 7 as we look at 6 and 7, but now we're not looking at the height of the liquid on the inside. We're looking at the height of the water on the outside is my H. And then on the third one, we're pretending that the water went all the way up to the top of the tank, and now that's going to be my height. So all that changes is my height. So just keep changing the L to this water height, which they call S for surge height, and then for the total height of the tank, which they call H. And you have solved all three.